My recording here. Okay, so here's Java. We're going to start in Eclipse a brand new project, and I'm going to make one called Forms, and then I'm going to see whether or not, well, let's just crack it open here. So there's the library stuff that you need and a place to put your source code. So I'm going to click on the little C for class, and I'm going to make myself a class, and I'm going to call it the student form. Okay, and that's the only thing I filled out. So you can think of any time I say Java class, you can think of it as just being a form that holds a bunch of information. And so there's what it does for us. And notice that this one, it built the student class and gave it the same name as student.java, but in this case, since I didn't select main, it hasn't put anything in there. And so now let's build this form, and I'll just do the Java equivalent for you for a start. So this will be string for first name. It'll be a string for last name, and it'll be an integer for, an integer for age. And there's the equivalent Java. And so in the Java version, that represents the name of a variable, and the variable has a spot where you would store whatever information. Okay? And the only thing that's different in Java is we have to be a little bit more explicit about the kind of thing that that variable is going to hold on to. So the first two boxes, we're expecting people to type text in them, and this box we're expecting is going to have some number in it without a decimal. Okay? So there's the student form. But this thing at this point isn't a runnable program. So what I'm going to do next is I'm going to do what we did the other day. I'm going to make another thing which we'll call a driver, or for student. I'll just call it a driver. And this time I'm going to select main like we did before, get rid of the comments like we did before, and start writing some stuff in main. Okay? So the other one, the student class, was a definition of things. Main is the thing that's actually going to do all of the work. Okay? So now we need to make one of those brand new empty forms. The way you make an empty form is you say student is the name of the form, so you tell what form you want to make. You give a variable that's going to hold on to everything in the form, and then we say new student, and that will create the form. Okay? So think of new as being a photocopier, and what we're doing is we're saying go find that student form, make a copy of it from the master someplace else, and we'll scroll the name student or someone on top of that to say this refers to some person's form, whoever it happens to be. Don't really know at the moment. Okay? So now we've got a brand new form. If you want to fill it in, you can say someone, you can make the wrong key here. You can say someone, and then that's the name of the form. And now if you type a dot, it will show you the pieces of the form that you can fill in. And what you'll see is that the top three we recognize as ours, and there's a whole bunch of other stuff that we don't care about. Okay? So just look at the stuff that belongs to us. There's the three variables that we made right at the top. So now you can select out of that thing any particular variable that you want. So I'll set that one equal to Fred. I'll set the other one, type the dot, last name, and we'll call him Flintstone, and we'll fill in the age. Like that. Okay? So that's just filling in all of the different pieces of the form. Okay? So the rule in Java is basically anytime you have a variable that's not an integer, you can type the name of the variable in the dot and then get at the pieces of it. Okay? if we wanted to do something like print it out, we could print out someone.firstname, and now we'll have a program we can actually run because it produces some output. And if you run it, the output appears down below, and I made the screen a little large so you can't actually see it. Just move it up. There we go. Okay, so there's the output from the program. The name Fred that came off the form. Okay, a couple of things about this. In Java, variables begin with a lowercase letter. Variables that are composed of multiple words, every word thereafter is capitalized. The only thing that gets capital letters is the classes that you write, so student and driver, which are the same as the file. So those are the things. And variables are sort of, I always think of them as being like people. There's who I want to talk to, and this is what I want to say to them, or what I want them to get to do, or what I want them to do. Okay, let's use the debugger on this program. We'll set a breakpoint at the first line of the program, which is that line, and we'll click on the bug to run it this time. Say yes, please remember always what my screen looks like. And I'm just going to make the screen a little narrower. I got that wrong too. You can see all the pieces. Okay, so there we are with the debugger. Notice that we've got a place for variables. If we use the debugger's step over command, which has conveniently disappeared for me, so I'll just cancel that and do it one more time. Sorry, it's just that my screen image has gotten distorted. Let's go back to Java. Hit debug. That looks a little bit better. Okay. Use the step over command, and now all of a sudden you see that in the variable window, the someone variable has appeared. Notice also that the someone variable has got a little triangle beside it. So if we open up the triangle, there's all of the current values of the stuff that's on the form. Right? And notice that currently they're all empty. So you can use the debugger one step at a time to see what happens with each of those statements. If I do one step over, it filled in the first name on the form. Do another step over, and it fills in the last name on the form, and do another step over, and it fills in the age. We can use the debugger to watch this thing do its work. Okay. Questions about that?
What are the values in this one?
Don't worry about those. Actually, we'll find out. We'll find out almost immediately. Let's just try a different example, and we'll see if we can make those things a little bit more clear. Suppose that somebody else walks into the room. We need another form for them. So you can make another form. So there's a second form, and you can start to fill that in. And Fred and Wilma are taking a class together. So notice that every time you want to make a new student or a new person walk into the room, you make a new form for them, and there's a variable that keeps track of them. Okay. Now let's just be a little bit more interesting. Suppose that I do this. And I spelled it right. Shouldn't have chosen a name I couldn't spell very well. When in doubt, copy paste. And let's just take this printout, and I'm going to slide the printout from there down to there. And there's your first exam question. So what I did here was I made another variable anonymous. It is referring to the same stuff that someone refers to. And now I changed anonymous's first name to Frederick. But when I did the print statement, I went back to printing out the original someone. So, what's going to get printed out? Am I going to see Fred Flintstone, or am I going to see Frederick Flintstone? How many votes for Fred? How many votes for Frederick? Now, when in doubt, run the program. It says, do you want to save it? The answer is yes, always. The Fredericks win. Okay. Well, let's just go and use our friend the debugger again. Let's put a breakpoint down at the new code. Let's run with the debugger until we get to that point. And then let's take a look and see what happens here. We've got the someone variable with those values, and its ID number is 18. If we do a step over at this point and look at the value of anonymous, anonymous also has an ID number of 18. So the answer to your question is, what do those numbers refer to? Those say that those two things are the same thing. They have the same ID number. And so if I change anonymous's values to something, then the values that are in the other variable will also change. So if you do a step over here, because they refer to the same thing, when you step over, it changes Frederick in the original text.
What would be the point of that if you just change the first thing rather than making something else change the whole time?
Well, they refer to the same thing. Believe it or not, that's normal behavior. And it's a perfectly reasonable behavior. Think of those ID numbers in the variables as holding phone numbers. And so if I've got somebody's phone number and I can talk to them and say, hey, from now on I want you to be referred to as Frederick when anybody calls. If I pass their phone number on to you, and you can talk to them, you can tell them to be different than they already are, and if I phone them up, all of a sudden I get a different response from them than what I expected because they've changed in the meantime to somebody else had access to.
That's the only reason why I didn't point out these two. Like, I guess you have that number, but I don't know why you want to. Yeah, a lot of people prefer someone to get one.
We'll find even better use for it later. And again, if you think of, I'll give you a hint, if you think of these things as containing phone numbers, then eventually we're going to get to the point where we put the phone numbers into an address book and then go back and dig the phone number out of the address book, so it's going to be stored someplace else, not necessarily in two variables that we have direct access to. So eventually it will become a useful problem. But the ID numbers will show you in Java when you're referring to the same thing versus referring to a different thing. And so the ID number of the other student is different for Wilma. She's got a totally different way, a different phone number. Okay? And notice that it's the debugger that helps you figure these things out. So the answer is, when in doubt, if you're not sure, run a quick test program and see what happens. And you can always use the debugger to step through and look at the values of things to find out if you're getting what you expect to get. The debugger will be your friend. Okay, so we'll kill that thing off. We'll go back to this view of things. And let's try something else. I said that this thing was a grouping mechanism that behaves like a form. The next thing that you want to typically do with forms is you want to prevent people from doing bad things to this form by putting information on that you don't like. And so the second thing we get to is being able to control the value that goes on to this form. Okay? So now I'm going to split my world into, I'll be a little bit bipolar here, I guess. I'll say that I'm going to play the role of being the main program, and I'm going to think of anybody else who has one of these forms as being one of my employees. And so if this is an employee, you can think of that data there as being the stuff that's sitting on their desk. And so whenever a student comes into the room, I'm going to hire just one employee whose job it is to record information about the student who walked into the room. Okay? And I'm going to tell the employee to do things now. Okay? So the employee, being a good employee, says, well, I'm a union member, and if this is a union job, you can't disturb the stuff on my desk. Because the last thing you want is a boss who reaches onto your desk, grabs stuff, and says, here, I'll do it myself. As soon as you hire somebody, the job is to let them do the work. And so they're going to put a big sign on the front of each one of these variables that says private. And the sign there just says, hey, look, this is my stuff, hands off. Okay? And when we save that thing, and we go back and look at what happened to the driver who's the boss, all of a sudden we get these what are actually red lines appearing here that says, oh, you're not allowed to do this anymore. Because this is going and scribbling things onto the form directly. Okay? So, if I can't scribble things onto the form directly, what do I have to do to get things changed?
Peer pressure.
One more word. Ask the employee. Right? I got to go talk to the employee who owns that stuff on the desk. And now it's, oh, okay, well, that's your job to change things. So, oh, would you mind changing the first name spot on this form to be this value instead? Okay? And so now the syntax changes a bit. Rather than me being able to access directly, what I'm going to do is I'm going to say set first name. And I'm going to change this thing, instead of being a direct assignment, I'm going to change it to what's a function, or what Java calls a method, which says I want you to change their first name. And let me go into the student class, and I'll add the equivalent thing that the student has. Let me just add a bunch of them, and then you'll see the pattern. That's probably the easiest way. And I'll give the variables almost the same name, so it's obvious where they're going. And I'm going to take this one and do it for last name also. And then you'll start to see the pattern. Make sure I get it right. And we'll do age too. I'll fix that in a second. Yeah, better fix that too, thanks. That's the trouble with cut and paste. It'll get you. And age equals image. And I'm just going to do that for a second. And then if we go have a look in the driver, every time we set it directly, we'll now put the brackets around it to make that a parameter to the function. And we'll put the word set on the front of it. and turn it into something that the function takes. Now, the ones that are retrieving values, I'm going to go back in here and I'm going to write the reverse, which is public string get first name. And I'm going to go back into the driver and change this thing to, where's one here, someone dot get first name, like so. I'm going to talk about it in just a second after I get them all fixed. That will be all of them. Okay, so let's look at the student class first. Originally, the student class just had all of its data groups together. Now what the student class has, or what this employee has, if you want to think of it in that way, is a job description. And this job description says, anytime somebody walks up to you and says, hey, set first name, they're going to give you a bunch of characters, and I want you to take whatever they give you and I want to copy it onto the form onto that place. So you can think if I'm walking up to my employee and I'm giving him a scrap of paper and I'm saying this scrap of paper has this information on it, could you please record that onto the form in the first name section. Okay? So this is asking the employee to take some information in and copy it into the appropriate place on the form, and those are just repetitions of the same thing. And there's a standard in Java that says if you're changing the first name variable, you should call this function or method set first name, just to make sure that now people know that there's a correspondence between that word and the variable that you're trying to change. It's not required, but it's nice and it's going to come in handy because it makes things easy to find, you know exactly what you're changing. And I tried to make this variable sort of match the name of where I was expecting to put it, so that when I write this line, it was obvious people picked up when I called this one in last name and tried to put this into a first name variable. You're going, no, right? If I would have called this string X, then you wouldn't have cared where I put X. So it's the fact that I gave them good names that helped figure out the correspondence. Integer is the same thing, only it says I'm taking a number coming in order to do all of that work. In the reverse, this is asking a question. I walk up to the employee and I say, hey, get me the first name on your form. And the employee says back to me, I'm going to give you a string back or a group of characters back. Okay? And that's going to be sent back to whoever asked for it. Another piece of paper comes out in that case with the information on it. So in the driver, what's happened is now you can think of this thing as being not only making a new form, but hiring a student or hiring an employee who's in charge of that form. So everybody who comes into the room, I give them make a new employee to keep track of their information, because I've got lots of money to do that. Right? Seems like a waste, but there's just one person in charge of one form in my organization. Okay? And the converse is when I want to get information from whoever's in charge of that form, then I go and I don't give them any information. I just say, tell me something about what you got on the form, and they supply an answer. In this case, the answer that they gave back, I just dumped out to the print statement, but could have done it anyway. Or could have put it into a variable if I wanted to. So normally, if you wanted to do it that way, let's put a variable in there. Copy that out, paste it into there, and change that thing to the variable. general rule is if ever you ask somebody a question, which is what this is, then you should take whatever answer they give you and store it someplace to remember what they said. If I left this off, I would be asking them a question and turning around and walking away and not listening to what they have to say. Okay? So put it into a variable and then print out the value of the variable instead. Okay? There's no magic to these forms. Now that you've seen me doing one of them, guess what? They all look alike, and they almost always have some combination of strings and integers, mostly in order to keep track of information. How do you choose what kind of information to keep track of? The normal rule is you try to keep track of only the stuff that you need and nothing else, because it costs you money to have to update this thing all the time with unnecessary information or information that's going to stale. So try to keep it to just the stuff that's important. Okay. Let's try something with the debugger now. I'm going to go back up to the top of the program, and I'm going to run with the debugger again. I'm going to do a step over to create the form. And now I'm going to do set first name. Okay? Now with the debugger, we've been doing step over. And if you use step over, it's going to treat that thing as if it were just a single line, and it's not going to care about how it does its work inside. Okay? But if you go and use this other little beast here, step into, it will step into the code for set first name and let you see what it does. So the debugger stopped here, and it says we've somehow switched into this file that's keeping track of student stuff, and we're about to execute this line. Okay? If you look in the window up there, you can see the variable in first name has got thread coming in. Where are these values in the variable window? Don't see them. There's our friend, the little triangle again. Java hides all of the variables for the current employee or student in this case under this variable. And so if you crack open the this variable for the form, you'll see all of the information there. And so now you can see what's going to happen here is that it's going to copy the value of the variable Fred into the first name variable on the form. So another step over, and there's the copy that's taken place. Okay, so we transferred the value from the scrap of paper onto the form. Now, when this thing is done, set first name, when the employee is done, who's going to get control next? Who asked them to do stuff? Me. So the control should go back to me somehow. See this little piece up here? This thing is trying to say, currently it's the employee at the top of this file who's doing something. The boss is waiting for them to finish, just like a normal function. So when set first name is done, we're going to go back to the driver program to the boss at line number 7. Okay? So when it runs off the end of this little bit of code that the employee has to do, he's done. He sends the result back to the boss, which in this case is saying nothing, it's just done, and now I'm going to get control. And so that point of the debugger is trying to show you who called who to get work done. And eventually it's going to get a lot longer. We're going to have A calls B, calls C, calls D, calls E. If it's a big company, there will be some big chain of events before somebody down at the bottom rungs of the business actually does something, and then everybody will report back saying, yeah, I did it, I did it, I did it, and work its way back up to the top again. For now, it's only 2 levels deep. And so when we do a step over, we're going to go back to main at line 7. You can click in here, and you can see that in this case, instead of a solid arrow, this thing is green, but it's an unfilled arrow. Probably can barely see it over there. The unfilled arrow means that thing is waiting until the function that's been called is done. And so that's where we actually are now. Notice when you click on these things, it only shows you the variables that are active for them. So in the main program, it only shows me the sum1 variable, and in the student class, it shows me just the values that are associated with the student variable, with this particular student variable. So when this thing is done, it's going to roll back into main. So we'll do another step over. And now we're back continuing on our way in the main program to do the next step. Okay? So we've now got, our company is now 2 levels deep. We've got me, the boss, doing things, and I've made a second level of employees below me that I can now delegate work to. Okay? And I can no longer access their stuff directly. I have to make up a job description for them. I have to ask them politely to do stuff and politely to bring stuff back. Okay? Which means the job description now inside the student class defines exactly what it can and can't do. Okay? So for instance, let's just suppose, we'll do the simple thing here. Suppose that somebody, we wanted to make sure that age was always a positive number. What I could do is I could go into the student class and I could go into set age. And I could say, if for some reason in age is less than 0, nothing to do here, just get out. Okay. This is not the best, necessarily the best form of error checking. This is the la 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 la. I'm not listening to your form of error checking. I didn't hear what you said because it sounded wrong to me, so I'm not going to do anything. So that return statement there says, oh, if the age is less than 0, then just get out. We're done. And so I've left the normal thing that we did sitting there. Oh, okay. If it's a valid age, then we're going to right? So there's the first 2 roles of the Java class. It's got the ability to group things together, which is a very common thing that you do. So you rarely see pieces of information, variables sitting by themselves. There's almost a group of variables that all work together to do something, so they're all associated together. And then there's the control feature of the only way that people can change things is by asking us, which is what those sets are doing. So when information is coming in, we have the opportunity to make sure that it's correct. And when it's going out, oh well, we know it's correct going in, so whatever they ask going out is probably wrong. Questions? Oh, okay. Let's take one more step. If we go back into the driver program, I printed out the first name. Suppose I wanted to print out all of the names. I'll just do that the long way. So there's the last name. Get the age. Notice the IDE will help fill in things for you. So long names are fine because you don't have to type very much. You just have to do the autofill thing. And I could print out first name plus a space plus last name plus a space. And Eclipse also has this feature where it tries to help you with your typing by closing off brackets and all that sort of stuff. And invariably, it just gets in your way, which is what it's doing there. So we'll add age in as information, and we could go through and we could print out all the information that we'd recorded for Fred Flintstone. So there's Frederick Flintstone. Okay. The only problem with this, even if we put the gets into here instead of the variables, it's still sort of annoying to do because I'm the one that's doing all the work of going, what's the first name you got on that one? The last name you got on that one? What's the age? Oh, thanks. Okay, now I'll print it out. You think of a shortcut? Well, I could get the employee to print it, but I'm going to be careful here because generally, from what I've seen of a lot of employees, you don't want them talking to customers directly. If you've ever seen, like, if you go to an auto shop to get your car fixed, and are wanting to do so, right? The guy at the front counter never lets you talk to the guys in the back because they swear a lot and they say strange things and they don't, they're not really used to working with customers. And so usually it's the guy at the front end who does the business of going and talking to the employees to say, I got a customer here in the outside world, let me go ask some stuff, get some information, and relay it back to the customer. So you're sort of on the right track. I don't want to have them talk directly, but
You don't have the employees get you the information.
just have the employee give me all of the information that you've got, right? So let's make our lives easier by doing something like this. We could replace all of that code with string talk to whoever they are, someone, and say someone dot get all information. Okay, and unfortunately I haven't written that yet, so let's go into the student class and let's give them some other thing that they can do, which is public string get all information. And what the employee should do is just make a list of all of the stuff they've got. So I'm going to say, I'm going to do this the long way on purpose. Result is starts out as empty. And the general rule is when you're sending something back in a programming language, what I like to do is make a variable that's going to hold the result. And then eventually we're going to send it back. So I can say return result to send back whatever we create, and then go back and figure out what you need to do. Okay? So in this case, I'm going to take result and I'm going to add to it first name. And I'm just going to use the name of the variables here inside the string. So that's string concatenation. Okay, so I basically took an empty string, tacked on one line for each of the variables I had, or sorry, one pair of values for each of the variables I had, and sent that back. And so now in the driver program, when we save all of the files, now knows about get all information equals would be nice. There we go. Need a variable name. We use the word result here too, and then we'll just do print of results. Just do a print of result and try that, and we should get two lines that say the same, almost the same thing. Okay, so there's the second way of doing things, is that I've now got the employee supplying all of the information directly to me. So what's the benefit of doing that? Easier, just ask them once, right? It's not me all doing the work. They're collecting all of the information inside, putting it all together onto one nice long piece of information for me, and sending it back. Okay? So the general rule in Java is that at any level you always try to be lazy. You always try to find somebody else. It's like being a middle manager. How do I find somebody else who I can push the work to so I don't have to do anything? Let me go ask somebody else. Let me go get somebody else to do something. If it's my job and I don't like doing it, push the work down and make it somebody else's job, which is exactly what we did here. Push the work down a level. Okay? Any other advantage to that?
You get the title or whatever, like the first name.
Yeah, this is just sort of a debugging tool more or less, so I can see what's going on. How about this? Suppose that I do this. Private string, we'll call it phone number. So I add in an extra piece of information onto the form. Okay? What should I do inside this student class? Yeah, and get all information. All that I have to do is go and add in this other line with phone number. Like so. And add the getters and setters. But for now, see what immediately happens here? In this version of the thing, I had to care about the information that the employee had, and I somehow had to magically know every piece of information that they were keeping track of in order for me to ask them about it. Okay? In this version, I don't care anymore about what pieces of information that they're keeping. I just say, give me everything you got, and that will work just fine always, regardless of how much information it's collecting and how much they're changing the doc to add. It's moving the work, and it's moving who has to know about stuff. Because typically the last thing you want in a company is for other people to know about your business. And so what we're doing is we're hiding our business of what information we're keeping track of so that people don't have to see it. I'll manage it myself, and if you want to know, I'll let you know, but it's me who's in charge of the rest. So you delegate the responsibility, now you have to delegate all of it.
And in the long term, it saves a lot of programming because it's easier to get a string to the first thing, string to the last thing,
Yep.
change to the thing.
Yep, it's simplified.
With this, you can just get all information.
Okay,
to
it's
that.
gone from 3 questions down to 1.
And you can get
Or
all
4 questions.
And you
down
can
to
get
one.
all the information to home on that, all for
Yeah.
noise.
So it works for everybody, right?
Then
So now notice that a Java class has actually got 3 useful things in it. First role is to group information. Second role is to control people's access to that information. And the third role is to provide some extra functionality so that it makes other people's lives easier because you're doing the work that they don't have to do. Okay? So those are the 3 things that a Java class is always good for. Okay? Now, one more shortcut. Because this happens an awful lot in Java, that you, as a programmer, you just basically want to dump out the result of, or the information for all of that stuff that you're storing, right? So as you're debugging, that's sort of, if you were back in the print days, that's sort of a nice way of doing things, right? Okay. So it turns out that they made a default for that, and instead of calling it get all information, it's actually called toString. And so this name in here as the standard is called toString. Okay, and if I did that just right, I think, did I spell it right? Let's see if it's happy with me. I guess I didn't spell it right. Find out. There we go. I must have typed a control character in there. Okay? So in Java, it's just called toString. So if you ever want to write that stuff for debugging, that's its standard name. But every time you see it, just think, give me all information. Now, to make it even shorter, you don't have to do this. And if you're just printing out the information, you don't even have to, you can say someone dot toString if you want. That will work. But the shortcut is to just not say it at all anymore. And it's smart enough to figure out, oh, since you're using that thing in a print statement, I guess you want a string being sucked out of the object. I know that toString will give me information about the object that way. So that will just print out the whole thing as a shortcut. It has to be called exactly that. And just let me, I'll show you something here. Let's just get rid of this. Notice it worked. Let's just get rid of it. Here's another useful feature. Under source, there's this thing that will automatically comment out stuff for you. So there's add block comment. So I made that entire thing go away for a moment. And notice now in the driver, when I run it, it prints out this ugly nonsense. Okay. So there's a default toString already that's built in that you get for free. The problem with the default one is that it prints out the object's memory address because that's the only thing it knows about it. It has no idea of knowing that there's a first name, a last name, or anything variable. And so what we're trying to do when we write our own is we're trying to hide the one that's there or replace it with a better one that does something better than printing out the memory address. So the bottom line is, if you print out a variable for a class that you declared in a print statement and you get a whole bunch of gobbledygook like that, it means that you didn't write a toString. Okay? And the reason for putting that little @override at the top like I did on the toString, that @override there is to say I'm planning on overriding the existing toString and doing a replacement with one of the one that's already there. And if for some reason you spelled this wrong, like you called it toSting instead accidentally, right, because you're a bad typist like me, and so if you call it toSting, that's a valid name, but now what will happen is the compiler will give you a warning. I'll just mouse over the error message. And the error message is basically saying, oh, you said that you were overriding something, but this isn't something that already exists, and so there's a problem. Okay? So @override is just a safety play to say, you know, the one I'm about to write here is one that should be around already. And so it's just a good thing to always put that on there, and it'll go, oh, no, you're not hiding the one that you thought you were hiding. Otherwise, what will happen is you're not actually replacing anything. You go and you write it, and you go, well, I got a toString, but it's just not working. Well, it's not working because it's not being called. It has to match exactly the one that it's trying to replace that happens to look like that. Okay, that was a lot of information, but we're going to do this same thing over about 3 or 4 more times, writing a complete one of these for a different problem, adding some more stuff to it to make it a little bit fancier. So don't worry if you miss it once, it's going to recycle again. All right, and we'll see you tomorrow.